What? What? Okay, time to go. Hey, you know why I'm wearing these? Because today's lesson is called the volume of a prism. And I figured, well, it's going to have to be loud. It's about the volume of a prism. Now, here I have a rectangular prism, and I'm going to see about its volume. Are you ready? Here we go. I don't hear anything. There is no volume to a prism. That's today's lesson. Thank you. Bye. No, actually, now, you know, when we say volume of a prism, we are not talking about how loud the prism is. Now, if it's a, you know, a radio box kind of thing, it could be kind of a lot of volume to a prism. But we're talking about here, how much can that prism hold? You know, so we aren't talking in a rectangular prism here, a box, about its outside, you know, like we want to wrap it for Christmas and give it to Mr. Frazier. No, we aren't talking about using wrapping paper on the outside. We're asking if you were to stack cubes on the inside, all right, how many would it take to fill it, all right? So, for instance, this would be about the size of a cubic inch, all right? I got an inch, all right? So a cubic inch, that's about the size of, how many cubic inches would fit inside a box? All right, so, or how many cubic centimeters would fit inside a box? So that tiny little cube is a cubic centimeter. In fact, I have a way to remember cubic centimeters. It's really sweet. It is really sweet. All right, if you go to the store and you get sugar cubes, will you ask for that next time somebody goes to the store? All right, you're in your mask or whatever, and you ask them, I can't understand. But, you know, sugar cubes are about the size of a cubic centimeter. All right, so here I have if you measured each of the edges on this, you would find it's about a centimeter. So you put those together. I'm not talking about square centimeters now. We're talking about these actual 3D shapes called cubes. All right, so here's a cubic. You know, what happened to it? It disappeared. I don't know what happened to it. Okay, let me get another one out because that one's gone. Okay, here's a cubic centimeter. Now, cubic centimeters are interesting. You think about how many could you fit into this box? It disappeared again. Well, that would be the volume of the box. How many of these could you stack inside here? All right, that is what we mean by volume. How many cubic units, all right? How many of these cubes could fit in there? Whether it's a cubic meter, cubic centimeter, could be a cubic mile. It could be any kind of size cube. But how many of them will fit into your box, your rectangular prism? So here's the key. When we find area, we multiply two things together, the length and the width. And since we multiply two things together, the units, whether it's meters, inches, are always squared. All right? Don't look at me when I say that, please. All right, units are always squared. You look, okay, anyway. If you find the volume of something, you're going to multiply the length times the width times the height. So how many things is that we're multiplying together? Right, 3. So all the answers, when you circle them, have to have an exponent of 3 next to the units. So centimeters cubed, that's a 3. Inches cubed, or we call it cubic inches, cubic meters, whatever it is, that is the exponent now we need in your answers when you circle in today's work. All right. Let's suppose I have these notepads, all right? So I have these notepads, and I don't know what to do with that cubic centimeter, so I'm going to dispose of it. The nice thing about them is they kind of melt in your mouth after a little while. It's just like this. I'm glad I don't get those kind of sugar rushes and sugar highs like I hear some kids getting, things like that. No, I don't do that. Oh, wow. You know, if you give me a lot of sugar, I don't climb the walls. No, actually, when it comes to, let's suppose we have a cube of notepads. All right, this is one cube of notepads. All right, I'm sorry, you know how they come together and they're all in a wrapper, that kind of thing. And let's suppose you have these cubes and you have a box and you're seeing how many will fit in there. And it's 3 notepads across the cubes of notepads, and it's 4 deep and it's 2 high. Not too high. I mean, it's 2 notepads high. How many cubic notepads would be in that box? Now you could just count them. Okay, 1, 2, 3, 4, 5, 6, 7. Wait, 8, 9, 10, 11. Looks like 12 in that one layer, and then there are 2 layers. That would be 12 times 24 cubic notepads would fit in there. Yeah, but there's an easier way. you know, mathematicians have found out there's an easier way to do this. All you have to do is take what we would say the length times the width, say, times the height. So you multiply those three things together. Let's see that. The length is 4 cubes here. I always take the longer one for the length. The width is 3. The height is 2. Length times width times height is going to be the volume. Now you notice we use a capital V. All right? It's a capital V. Not a lowercase v, but a capital V for volume. All right? So volume equals 4 times 3 times 2. Length times width times height. So that equals 24 cubic notepads would fit in there. So you don't have to have the actual, you know, notepads and all that. You know, it would be 24 of them. Now that's a lot simpler than yesterday's. Remember yesterday finding the surface area? Ooh, area, surface area of a rectangular prism. Area equals 2 times the length times width plus 2 times the length times width plus 2 times the length times width. Yeah, that's a pretty big formula. But today's formula is pretty simple. Let's say the volume of a rectangular prism's formula. Ready to begin. Volume equals length times width times height. Let's try it again. Ready? Volume equals length times width times height. Not everybody's saying it. Okay? Little brother too. Ready to begin. Volume equals length times width times height. All right. Now, let's just try to figure out one here. Let's suppose this is one that you're actually doing for number 4 tonight. It's a suitcase. And you want to know how many cubic inches would fit inside your suitcase. All right, let's suppose your suitcase is 31 inches for the length, 17 inches for the width, and 13 inches for the height. Pretty big suitcase. And you're packing it to go on your first trip, all right, for seems like forever. Okay, so remember, a cubic inch is about that big. And so you imagine your suitcase. How many of those cubic inches could you stack and fill that suitcase with? All right, so here's what we'll do. Instead of actually doing that with little cubic inches, we will instead use the formula. Ready? Begin. Volume equals length times width times height. All right. So I have a length of 31. So volume equals 31. A width of 17. It's times 17. And a height of 13. Now when I multiplied all those together, I get 6,851. So the volume, or the number of cubic inches that could be that would fit into your suitcase is 6,851 cubic inches. Notice the exponent has to be 3 when you're doing today's practice. The exponent has to be 3. All right, here's something else you're going to run into. Find the missing measure. That's like a little clue that he gives you. And now you're going to be, you know, Herlock Sholmes, and you got to find out what is the missing measure. Well, let's suppose you're given the volume. It's 112 cubic centimeters. That would be 112 of these. This is a sugar cube, but we, for science and math's sake, we don't call it sugar cubes because that would be not healthy for me to keep doing that, to eat sugar cubes. No, I'm eating cubic centimeters. So when you go to the store, ask for some cubic centimeters. You want to know what a cubic centimeter size is? Get some Domino's sugar cubes. And you'll have all the cubic centimeters you need to practice on. Now, find the missing measure. The length is 16 centimeters. The height is 3.5 centimeters. Can we find the width of a rectangular prism that has this information here? Surely we can. Let's say the formula for a rectangular prism. Begin. Formula equals length times width times height. What's the volume? I'm sorry. Let's say the formula. Ready to begin. Volume equals length times width times height. So what is the volume? I tell you it's 112. So I replaced V with 112. What is the length? I tell you it's 16. So I replaced L with 16. What is the width? Well, we don't know. Okay, so I put the variable W. What is the height? Well, I tell you 3.5 centimeters. All right, so I'm going to work this out. 112 equals 16 times 3.5 is 56 times W. What times 56 is 112? Well, I divided 112 by 56, and I got 2. 2 times 56 is 112, so W must equal 2. And I'm going to put it as 2 centimeters. Notice it's just centimeters. I'm looking at the width. I'm not looking at the volume. Only the volume is written in cubic centimeters. The rest are just units. Right? I got one more thing, and it's a challenge. All right? These challenges are something. Here we go. Number 20. This is a big hint about number 20. Let's suppose you're talking about a cube. It's the surface area of the cube. Now it's not a box, you know, it has a longer length and a shorter width and all this and height. We're talking about a cube that's the same on every side. All the faces are squares. Don't look at it. All right, all the faces are squares when you have a cube, all right? So let's suppose the total surface area is 726 square feet of surface area. Can you find the volume if you know it's a cube with 726 square feet of surface area? You sure can. First off, how many faces are in a cube? Okay? Well, how many, you know, well, 6. There are 6. So if I divide 726 by 6, I'll get how the square, you could say, don't look at me, the square units for just one of the faces. So 726 divided by 6 is 121. So one of the faces is 121 square feet of area. All right, so here's what I did. 726 total square feet for the whole cube. It has 6 faces. So I said, I'm going to divide that by 6 and get the area of one of the faces, which is this, don't look at me, square, okay? 121 square feet. Now we know, you know, if you have a square that's 121 square feet, that the area of a square is S times S, or S squared. So what times itself equals 121? 11. 11 times 11 is 121. So one of the sides must be 11 feet. In fact, all the sides, the length, the height, the width, they'll all be 11 feet because that's a cube. And all the sides have equal measures. All these edges have equal measures. All right, so since these have equal measures, the length is 11, the width is 11, the height is 11. So I'll say that volume will be 11 times 11 times 11, which I got is 1,331 cubic feet of volume. And yes, you can do it. All with a cube, all you have to do is know the surface area and you can find its volume. You try it at home, all right? Now, look forward to seeing you next time. Bye-bye.